Thanks, Chelsea, for the introduction. Hi, everyone. I'm Sarah, here with my colleague Alejandro. We're from the Government Technology Agency of Singapore, and today we're very excited to be here to share with you about some work that we've done in collaboration with SkillsFuture Singapore, which is another government agency that looks into lifelong learning. So before we go into what we did, some context about why we even chose knowledge graphs for this. I think anyone who works in the jobs and skills domain knows that there is a whole lot of data out there about many different parties within any jobs and skills ecosystem. We have individuals who are thinking about their own careers and they want to make informed decisions, whether it's about gaining new skills or more skills to be better at their current jobs, or really to make an entirely new career switch. Then you have employers who are really concerned about what they need to make sure their employees can do and how to fill the gaps that they have, whether that's through hiring or learning and development strategies. And of course, on the other side of the market, if you want to think about it that way, you have training providers and educators who really need to align their curricula to the demands of the labor market and ensure that what they're teaching is relevant. And all of that, of course, is put together within an economy in which we all want to have a competitive workforce with fewer skills gaps. What this means is that we really have data from a very wide number of sources, whether they're like resumes, job postings, course descriptions, and various other things about the state of the economy and the job market. And what we found was that actually we faced an issue where the best way to get meaningful insights out of the data was that we needed to connect all the different entities and to layer on additional information to the connections that are made between all the different data points. And so now I will let Ale share more about what we did to do. Oh wait, no, sorry. I think I forgot. I should also give you some context about who we are in the first place. So now I've given you a context about the problem. I think the role that SkillsFuture Singapore plays in Singapore is that it's really focused on helping two different parties, employers and individuals, in upskilling. And the whole point of that is really to make sure that people have skills that are relevant to the job market. And they do this through programs and funding. If you don't know where Singapore is, we just included a map to show you where it is in Southeast Asia, and we've included a picture of our team because we're a team of data scientists and data engineers who support SkillsFuture Singapore in various ways. And so now Ale will share more about the work that we actually did building the graph.
Nice. Thanks, Sarah. All right. So just to recap, we're talking about skills, jobs, occupations. So we need to find a way to bring that all together. So like Sarah mentioned, we found ways to connect it. And the best way to do that perhaps is a knowledge graph, which is also why we're here. So what I'm going to do now is I'm going to walk you through what entities we selected and how we go ahead and connected them. So maybe if we can start seeing them on the screen, we can start with the first ones, which is like the expert part. So everyone knows data, right? But we actually had a wealth of expertise. Think of consultants, people from different engagements that can give you their opinions or even tell you how their company does a certain job. So SkillsFuture had a wealth of information in terms of what is knowledge about occupations and skills sectors and how they relate. So we had that wealth of data in a way that we had to leverage. But that's just one part of the puzzle, right? What about something more changing, more like dynamic? So the other part that we can see now on the screen is the aspect that involves the labor market. So think of job postings. Like you open like your newspaper, your LinkedIn, and you will see that there are jobs, they have skills requirements, and they have other things that you might need to understand and that they might change every month or every year. Some occupations, although the name is retained, actually change over time. So just because a software engineer was using a certain programming languages 10 years ago or 5 years ago or 1 year ago, doesn't mean they'll continue to use it in the future. So up until now, I mentioned we have this like expert-driven data set. Now we're looking into things that are very dynamic, like job postings. But there's also one more element that I want to introduce. And that one has to do with courses. So think of education now. So not only like I must take a course to upskill myself, but the course should be available for me to take it in the first place. So we can see how for the economy to flourish, we need the jobs, we need the people with the knowledge, but we also need to get somewhere to get that knowledge from. So that's how we're trying to map all these elements that are very interrelated, and the skills is the entity at the center of it all. So I'll give you just two more comments on how we did this on a high level. So first is on how we managed to link. So in this case, we're using some proprietary machine learning models that are used to connect these sources of data. I won't go into the details. It has to do with specific taxonomies that Singapore uses to classify occupations. Same for skills. But if you were to do this, you could go ahead and use any machine learning model that will do some sort of entity recognition at the end. And what you want to do is be able to say, well, this course is talking about this occupation, and this job posting is also talking about the same occupation in the same taxonomy. At that point, you have a link. So that's the part on linkage. But things change, right? Like we know that, for example, prompt engineering could be like the new up and coming skill. We know that things like Kubernetes was not around 10 years ago. So we must keep space to have some fluidity. So that's why we also choose a graph, which is schemaless, or at least we don't need to commit to a schema up front, meaning that if there are new jobs coming in, or actually there's occupations that are disappearing in the sunset, we can also choose to add, remove. So yeah, that's roughly what we have for the graph. In the next slide, I want to show you an example. So in the slide you're seeing now, this is actually a screenshot. Our graph is huge. It has like around 40 to 50,000 nodes. Majority are courses, but we have over 1,000 occupations from this specific taxonomy called the SSOC. And the relationships between these entities are in the neighborhood of 700,000. So obviously we cannot show you the entire graph here, but you can get a sense by just looking at what's connected. And don't try to read the fine print, it's perhaps too small. What I want you to take note of is the legend. So think of sectors connected to occupations, connected to skills. And then you can get those skills from courses. And this is the gist of it. This is like the main building blocks. So we can improve this graph by adding new courses as they come into the market, adding new skills as they are discovered by being sufficiently different from other existing skills. The same for occupations. Sectors is something that doesn't change as frequently, but it could be a potentially, let's say tomorrow we have a new, totally different sector in the economy that can be added. And naturally, for example, whatever is available in the Singapore economy might not be the same in other countries. So for example, there's not a lot of mining that takes place in Singapore, but that could be different in different countries. So it's important to have flexibility in whatever system we choose so that we can reflect that through our nodes and edges. Okay, so this is just a glimpse of one example. Let me walk you through now some additional considerations we need to have. So we spoke about the job market and how it changes, and so do the skills change, right? So we need to keep an eye and monitor how skills evolve, how the jobs evolve, and we must do this so we can anticipate the needs of the future economy. This brings about 3 points. And one is we need to keep the skills relevant. So we need to make sure that the skills that we have in our graph are skills that someone needs to do a job. Two, we must make sure that if there is a skill that is growing in importance, well, then there should be some learning or education to provide some supply of professionals that have those skills. So learning also must be part of this equation. And then also we must consider if we have a huge gap or a huge delta between the needs from jobs, but the actual supply of people educated, that's also an issue. So to have this adaptability, we need to keep a track of these skills and job roles. So this immediately tells us that a static knowledge graph, like once and done, and that's it, will not work. That's why we couldn't just use the expert knowledge, even though it's very well curated. It was the work of years and whatnot. For some occupations that don't change very frequently, that might be acceptable to some extent. But for fast changing occupations, typically tech, but it could also be in other areas, that would just not do. So we must consider a dynamic knowledge graph. So this is the main reason why our job was a bit harder than we anticipated. But what I want to tell you now is how we manage this difficulty, this dynamism that was required. So what you see on the left is just a simplified way of explaining what we did, and I'll go into some details afterwards. But what you need to get is this. Picture two sources of data. One, I mentioned, is the expert knowledge. Think of that as a very well curated Excel spreadsheet. It's very tidy. The data is like in the right format. It's ready to go. It was done some time ago. Maybe every now and then you'll have some updates, but it's a nice data set. Okay, that already tells us some information between occupations, skills, and we can already quantify a bit from there. But what about the labor market? Well, that changes all the time. So we need to find some cadence. It could be monthly, quarterly, yearly, but we must essentially sample this market. So we can take job posting portals, we can gather data from them or buy it. And once we are able to produce a data set of job postings with timestamps, we can then go ahead and apply this machine learning models that I was mentioning earlier to extract the entities. So that allows us to say, well, I have a job posting. This now becomes a relationship between an occupation and a skill. So let's imagine that we're doing this by years. So let's say in the year 2019, we had some expert knowledge input that we can see as a dotted line. And then in the years 2021, 2022, etc., we are able to establish another relationship. And these relationships are quantified, by the way. We can use the amount of jobs we find as that quantification. So with that in mind, we can see that we have expert knowledge from one side, we have the labor market on the other side, and it's actually multiple points of the labor market. So this is all well and good, actually gives us a lot of understanding of the evolution, but it's kind of difficult to use. So what we did instead, and this is thinking that we must give this to analysts whose jobs are not like, they're not data analysts, they're not data scientists, like these are people who are focusing on the policy, on the execution. They need just like simple, fresh information they can act on. So that lets us to think of a different representation, much simpler. So if we change it to that, we can see that we can just simplify it to what we call an updated relationship, meaning that we can keep all these other links I mentioned, but we should have one that is like our overall updated relationship. So that if someone wants to know, just tell me the latest, tell me what's like the facts right now. We can use that instead. So how do we do this relationship? It's quite straightforward. We have two considerations. One is that we want the labor market as fresh as possible, the better. So if we're looking at job postings from 10 years ago, those should not matter at all. Like the economy might have changed dramatically since then. So it's a bit useless actually to look at that, which is why we define what's called a sliding window. So if every year we move the window a little bit, once you're out of the window, you don't exist. Second point is a weighted average. Again, things that are recent should be weighted more positively or more importantly. And things that are in the 2, 3, 4 years ago should be increasingly or vanishingly less important. With these two terms, we can come up with a very simple algorithm to define what is the weight that we're using and how we can put it together. One last point is that expert knowledge, we cannot treat it like this. We only have expert knowledge in certain years, in certain moments. We don't have a refresh of that. It's very costly and difficult. So this is a discussion we had with the people implementing it and using it potentially. So we decided to keep expert knowledge fixed, something that does not age, does not decay, but it's to be tuned or balanced. So a lot of this has some room for like tweaking, but what I want to leave you with is that we're considering the labor market, we're considering the expert knowledge, and we're trying to give our users a sense of like, what's the latest, what's really going on. And if you want more data, if you want to like track a certain evolution, then that data is also available, but that will be for a more expert user. So up until this point, I introduced our dynamic knowledge graph. So now I think Sarah can walk us through what to do with it.
Yeah. So thanks, Ali, for that. So I think we shared with you that quite a lot of work went into building the knowledge graph to connect all sorts of different entities within the jobs and skills space. Obviously, after doing that, we wanted to be able to provide useful insights to people. And what we found, our experience with this was that initially we thought, oh, maybe some of the analysts can try to learn Cypher. And we did, run some sessions to try to teach them, give them on-the-job experience. But it was really quite challenging in some ways because they're not really data scientists, and data is not necessarily like what they do every single day of their work. At the same time, there are those end users who actually don't even need to know that you have a knowledge graph. They really just have problems, whether they're like, oh, I want to know what job I can move into, or maybe within an enterprise, an HR team is looking at a certain area where maybe they need to move people into another area of work, and how do they do that? So we ended up grouping the users into two different kinds. The first was really analytics users who are looking at the jobs and skills knowledge graph almost like another engine from which they can get different types of data, and from which they do this quite repeatedly, and actually they do it at scale as well. They don't necessarily have Cypher knowledge, but they're quite good at self-serving insights. And so what we did, how we approached that was we built a prototype web portal with some APIs. These APIs really rely on fixed Cypher queries with parameters that can be input by the users. And it allows them to do batch querying of the graph, and to do it repeatedly whenever they need to do that. This can inform maybe certain reports that they need to put out, or even certain digital products that might be used to support end users, whether via certain maybe portals like jobs portals or even training portals. For the next set of users, which, well, we just call them end users because it's quite a broad group. And as I said before, they don't have a need to know how the graph works or how to use it. We found that a free text interface is actually quite a useful way to do that because it allows them to query it very flexibly. They can just type in whatever they want and they'll get some form of answer. And it also allows the insights from the graph actually to be combined with other sources of information. This can come in the form of existing relational databases or even reports, because there are a whole lot of kind of skills and jobs intelligence reports that are published both by SkillsFuture and many other organizations at regular intervals. One thing to add about this was actually we started experimenting with it before kind of GraphRAG really took off. And we started with just basic function calling at the end of last year, when that was kind of a new capability. I mean, LLMs have moved so fast since then that obviously that seems a bit archaic now. But we started with that, and along the way, we've experimented with improving the approach. The latest one we've tried is really the vector search plus graph traversal capabilities of, I think, Neo4j's latest Python GraphRAG package, and it's proved quite promising so far. So now I'll just do kind of a short demo of both approaches to give you a sense of what we did. So the first one is really the prototype web portal, as I shared. The video is a little bit quick, so I'll talk over it just to kind of point out maybe what you should be looking at. But don't worry if you can't catch everything, I'll just let it replay. So you can see the first page of the portal, and then you can see we have a whole set of pages, but I'll focus on this one called Growth Role Transitions. And it's really thinking, let's say I'm a manufacturing engineer and I want to look at what are some possibilities for me to transition into. Maybe I'll just return you the top 10 because you want different ways of analyzing the data. And then we can return a whole bunch of data that we actually store in the graph. Some of it is just properties, some of it is derived from relationships in the graph, properties such as wages, job counts, and then things that are derived from relationships are things more like similarities between occupations. And then based on that, actually, because we also have skills in the graph, we can then layer on an additional sort of tool which helps you to optimize a certain combination of causes that you can take to fill the skills gap. As I shared earlier, this is really not for the public who might have very specific queries. It's more for people like job skills analysts who maybe need to write some sort of report and really are interested at looking at maybe a whole suite of occupations in order to put insights out there about transitions that people could be looking into according to the latest market and economic dynamics. Then for the free text approach, what we tried earlier was what I mentioned, it was function calling. This was actually a very, it was a combination of basic document retrieval augmented generation on the skills demand for the future economy report, which is something that Skills Future Singapore produces every year, along with a bunch of graph and actually relational database APIs that allowed it to then actually query them for different kinds of data-related questions. We did have a pilot Telegram bot that we did a limited release to certain members of the public at some events. Generally, the feedback was good. And because the public found it to be quite an interactive way to find information from what can often seem like quite an overwhelming mountain of information out there. But obviously, as tools have evolved over time, we've also looked into how to better leverage the strengths of a graph. Because when you do, the previous APIs that we had were very fixed Cipher queries. You just put in parameters, you get the answers. And we felt that it wasn't quite taking advantage of the structure of the graph, where actually sometimes you want to be able to traverse beyond maybe the occupation, the one occupation that you're talking about. Or if you're asking about that, you then also, maybe I'm asking about it, but the answer would be helpful if you then start to just tell me actually what else is similar to it, what skills are related to it, and actually what courses teach those skills. And so this is why we started experimenting in GraphRAG so that we could ground the answers in nodes, relationships, and properties in the graph. It's a lot of text, but basically the question is really about if I'm currently managing a job and I want to change job, what kind of things can I look into? And we find that from the vector search and graph traversal, actually where the chatbot is really able to give answers that tells you quite a lot already about skills that you have that are transferable, skill gaps that you might need to look into filling, actually how common the transition is in the market, and of course certain fixed information about like wages and obviously demand, which are very important to consider when making any transition. I will qualify that a lot of this is work in progress and is not really in any live products at the moment. We have many colleagues who are really working on user research and things like that to understand kind of what our users need and how we can fit some of this experimentation into those products. But we thought it would be very useful to share because this is a very quickly moving space, and it's always useful to hear from other people as well about how they've experimented with using GraphRAG to make whatever information or data they have accessible to their users. So thanks very much for listening to our sharing today. I hope it was interesting. We have about 6 minutes left, so we're happy to take any questions if there are any from the crowd.